Okay, folks, so we're going to start today by connecting what we did on our last video to what we're doing today. So last video, we worked on those one-step equations, right? One-step equations. And today, we're going to start by doing one-step equations, but this time, we're going to do them out of word problems. So we're going to look at a couple of word problems that we're trying to do one-step equations from, okay? So you may or may not be able to read this up on the board, but it's mostly for me, okay? If you zoom in, I'm sure you can read it. If not, these problems, 7 and 8, are on page 441, okay? So you can follow along there. These two are on 441. And these two, this 7 and this 8, are on page 450, right? So that's 441, and these are on 450. So let's jump into problem 7. It asks us, or it tells us, I suppose, last week, Tiffany practiced her flute for a total of 7 hours, right? For a total of 7 hours. It says this was 2 hours, this was 2 more than she practiced the previous week, right? The previous week. So, how many hours did she practice the previous week? Okay, well, we don't know yet, right? So if we don't know what the previous week is, right? Let's use a variable, right? In math, we can use a letter to stand in place of a number. So instead of using previous week, I don't know what she did, but I know it was something. So I'm going to use a W for the previous week, right? And we know that it was 2 more than the 7, right? It was 2 more than the 7. So we need to do 2 things, right? We need to figure out what the word more than means, right? So 2 more than. More than means adding, right? This is going to be addition. So I'm going to go ahead and say W plus 2, right? Because it's 2 more. Last week was 2 more than 7. So I'm going to say this is 7 equals W plus 2. Let's just kind of write out what these letters and numbers stand for. Let's make sure that we're kind of backwards checking our work. So this was last week. This was the previous week, right? And this just means 2 more than, right? And let's look at it this way in retrospect. The previous week plus 2. 2 more than last week, right? 2 more than the previous week equals last week, which is what we want, right? We want 2 more than 7, okay? Or 2 more than that previous week, okay? So let's go ahead and solve this equation, right? If we have 7 equals W plus 2, right, this is what we did in the last video. Solving means we need to get the variable by itself, right? We need to get this W all by itself. And to do that, we do 2 things, right? The first rule is to do the opposite, right? So this is plus 2. The opposite of adding 2 is minusing 2, right? That's the first rule, minus 2. Do the opposite, okay? The second rule then is we have to do it to both sides of the equal sign. So we've done it over here on the, on the right side. We need to minus 2 over here on the left side. If you remember from that last video, opposites cancel, right? That's why we do it. So W equals, what is 7 minus 2? 7 minus 2 is 5. This one is W equals 5, right? And we can check our answer. Let's see. Is 7 2 more than 5? Yeah, right? Right. She did 7 hours this past week. That's 2 more than she did the week before, which was 5. This answer checks out. Let's look at problem 8. It says in a recent, I don't know when this book was published, but in a recent presidential election, Ohio had 18 electoral votes, right? All right, it says this is 20 less than Texas had, right? So how many votes did Texas have, right? Texas. So this one's kind of tricky, right? Because we're kind of working backwards a little bit. And the second part of this is that it says this is 20 less than, right? So the key word in problem 7 was more than, and in this case, it was less than, right? This is 20 less than. So do we know how many Texas had, right? Do we know how many of these votes Texas had? Well, the answer is no. So let's let's use that as our variable. I'll use a T for Texas, right? And Texas had, this is a tricky one, right? It says it was 20 less than. Less than means to subtract, right? If more than means to add, less than means to minus. We're going to say T minus 20, right? This is 20 less than Texas. 20 less than Texas had. And what's it equal to, right? This word is, right? That's kind of like an equal sign. Is a good job of telling us where the equal sign goes. If you look back at this problem, there isn't an is, but there's a this, right? And this, this was maybe, right? Was is like, is like the past tense of is, I believe, right? Is, was. So the was and the is the equal sign. So it is equal to what? Well, it's equal to 18, right? Because Texas there's 20 less than 20 less than Texas is Ohio, which is 18. So we check, right? This is Ohio's votes. This is Texas's votes. And this is 20 less than. So let's just see if this makes sense, right? Let's check our answer. 20 less than Texas is equal to Ohio. Yeah, that's what they're asking, right? 20 less than Texas is Ohio, is 18. All right, so that's our equation. Now we need to solve it, right? One-step equation, right? Let's figure out how many votes Texas actually had. 18 equals T minus 20. So we're going to do step one. Step one is to do the opposite. Opposite of minus 20 is plus 20. Step two is do it to both sides. So if I add 20 there, I will add 20 here. These opposites cancel, right? So T is equal to, I think 18 plus 20 is 38. Looks like Texas had 38 electoral votes in this problem. Okay, so let's go over here to problem 7. Problem 7 says Antonia earns $6 per hour. This is an immediate signal to us. The word per is telling us they're timesing, right? It's telling us it's timesing, right? So per hour. Let's keep that in mind. $6 per hour. Write and solve an equation, right, which is what we're doing, to find how many hours she needs to work to earn $48, right? So if she wants to earn $48, right, that's what we're trying to make it equal to, right? This is how much she wants to make, right, $48. Although when we use an equal sign, we don't ever use the dollar sign. So I'm just going to use a 48, okay? So how many hours, right? That's the question. How many? Well, we don't know, right? We don't know. And so that means that's going to be our variable, right? That's going to be our variable. So I'm going to use H for hours. And how much is she getting per hour? Well, the answer was 6. And per means multiply. So 6 times the amount of hours, 6H, is equal to 48, right? That's our equation. We've written it. Step 1. Now we need to solve it, right? So let's do, solving is getting that H by itself. Let's do the opposite first. What's happening between the 6 and the H? Well, they're timesing, right? The opposite of timesing is dividing, right? And if we divide on one side, we must divide on the other side. The opposites cancel. We're left with H equals, and if you use your calculator, if you don't know, 48 divided by 6 is 8. Right? And so it's $8. If she makes $8 an hour, then she can make $48 if she works for 6. Sorry, not $8. This is hours, right? So if she works for 8 hours at $6 an hour, then she will make $48. Right, so this one's a little different, right? This one is a little different. They're telling us in the instructions to use this formula, okay? So you may have seen it before. I'm just going to kind of fill us in. R stands for rate, which is like speed, okay? The rate of which you move or something moves is the speed, okay? D stands for the distance, and T stands for the time, okay? So we're going to look at time, distance, and the rate, the speed. So let's just kind of look through our look through our problem and know that it's going to end up looking like this. So do we see a rate? Do we see a speed that we're going, right? And it looks to me like it says a shark can swim at an average speed, there's speed, of 25 miles per hour, right? So 25 miles is our R, that's our rate. So I'm going to put 25, right? Rate is like a speed, equals. Now, do we see a D, right? Do we see a distance? Well, it says how far. Far is a distance, right? Far is a distance. But they don't tell us, right? That's what we're supposed to find. So if we don't know what D is, let's leave it as the variable. Let's leave D as D. Let's make sure we have a T, a time. All right, so it looks like how far can the shark swim in 2.4 hours? That is this bottom. That's the T, right? So our equation looks like this. I just substituted, right? Old vocab word there. Substituted R for 25 and T for the 2.4. I'm going to spin over here, get my eraser. All right, let's solve this equation, right? Do the opposite. This is a tricky one. What's happening, right? What's happening between D and the 2.4? Well, they're dividing, right? Fractions are division. So I'm going to times by 2.4. That's the opposite, right? That's the opposite of division is timesing, multiplying. So I times by 2.4. And if I do something to one side, I must do it to the second side. I will times by 2.4 over on this side. So let's look. And I know I'm out of the screen here. These opposites cancel, right? So we're left with D, distance. 25 times 2.4. I don't know that off the top of my head, but I will times it right here for us. 5 times that is a 20. Carry the 2. That's a 10, 12, 0. That's a 4, 8. And that's a 4. Okay. 0, 0. Looks like, yeah, 6. Okay. Looks like it's 60, right? 1 decimal spot. Looks like it's 60. It can go 60 miles in 2.4 hours. That's a long way. 60 miles in 2.4 hours by this random and generic shark, right? Because all sharks have different fins and they look different, they swim different. Okay, so that is part 1 of today's lesson, right? That is part 1, okay? And part 1, I want you to go ahead and pause this video once I want you to try a problem for me, okay? So I want you to try 2 problems, okay? I'll read the answer to you here in a second, but on page 443, okay, go to 443. I want you to try problem 23, right? So 443, try problem 23, and then I want you to try a second problem for me, please. Can you go, please, to go to page 451, right? And 451, I want you to try problem 11, okay? So 443, I want you to try problem 23, and 451, I want you to try problem 11. Pause the video while you work, and I'm going to read the answers to these when you're back. Okay, so number 23, right? Number 23 on 443, my equation was x, and you can use whatever variable, but x minus 13 equals 79, right? And you can write that backwards. You could say 79 equals x minus 13, okay? When you substitute, right, when you solve, right, when we solve for x, it looks like x is 92 points. X is 92. The second problem I want you to try was problem 11, which is just like this formula we use for problem 8. So problem 11, you should have had 205 equals d over 3, right? We're still looking for distance. And when you solve, it should be 615 miles, 615 miles. Okay, so we're going to transition, right? As I promised, we have a second part of this, okay? And I'm going to go ahead and just erase this. I'm going to go right back on our problem here, or right back on our board here. please join me on page 458. 458, please. I don't think I need all this space. All right, so 458, we're going to start with example one. So this one, okay, cool. This is going to tie in exactly with what we're doing because these are still one-step equations, right? One-step equations. The main difference, okay? The main difference here is that instead of timesing or dividing with whole numbers, we're going to be using rational numbers. We're going to be using decimals and fractions, right? Decimals and fractions. So that's the main difference here. Okay, you can already see right now we got some fractions in here, but one step, right? We can do one step. It's not that scary, right? We are that good at math. So D equals 5. Okay. All right, so I think we're just doing these three, right? We're going to take it very slow because we just need to get a little bit of safe instruction here, right? It's a very safe practice. So let's look. Remember that solving means to get the variable by itself. So I'm going to try to get this n by itself. I'm going to try to get this d by itself. I'm going to try to get this x by itself, right? What I mean by itself, I mean on one side of the equal sign, right? So over here, there's a 0.25 next to the end. I want to get that away, right? Over here, right, when I say, there's 3/4 by the end. So I want to move that fraction, okay? And over here, I have this -7/9. I want to move that as well, okay? So when you hear me say get the variable by itself, that's what I'm talking about, okay? That's what I'm talking about. And we have two rules to follow, right? The first rule is to do the opposite. So when we look up here, we look at this fraction, 0.25, what is currently going on? What's happening between this 0.25 and the end? Well, they're being times, right? When we see a number, a variable bunched up like that, they're being multiplied. So the opposite of that, right? The opposite is to divide. And remember, I use fractions as division because fractions are division. Okay, so I'm dividing, right? Dividing. Okay, and if I do something to one side of the equal sign, I must come over here and do it to this side. Okay, and I do it to this side. Okay, so these cancel, right? That's the reason we do the opposite, because we want them to cancel, right? And I'm left with n. And this part, right? This part you might need to use your calculator. It might creep you out. 16 divided by 0.25. 16 divided by 0.25 is 64. That's a big weird answer, but you can check me on the calculator. Okay, so one step, right? We can do one step. I'm mostly concerned about fractions, right? Because decimals will be a little easier than fractions, okay? So on the fraction one steps, right? I'm going to make us do these by hand, right? You're not going to be able to use a calculator for the one-step fractions, right? Because we know how to do this, right? So let's slow it down and let's really focus, right? Because all of the information you need to do this problem, you already have, right? I've already taught you, or math teachers in the past have taught you. So first off, what's happening between the fraction and the variable? What's going on with a number and a variable that are bunched together? Well, it's timesing, right? It's timesing. So we need to do the opposite, right? The opposite is to divide, right? I'm going to divide by 3/4. Okay, I'm going to divide by 3/4, and I'm going to do that over here like this. Okay. So remember, we do the opposite, right? The entire point of the opposite is because we want them to cancel. That's how we get the x by itself, right? You can see x is now by itself. And what we have to figure out is how on earth do we divide fractions? Well, the good news is we have a mnemonic, right? There's a phrase that I use, and I think some prior teachers have used with you. And that phrase helps us to kind of remind us of what to do and how to do it. And that acronym is K, C, F. K, C, F. I'll give you a chance. If you can think of that on your own, KCF, what does it stand for? Keep, change, and flip, right? This is keep, change, and flip, right? Keep, change, and flip. So just a crash course reminder, yes, right? The keep, right, the K, the keep is talking about this first fraction, right? We're going to keep it the same. So let's just write 12 over 20 down here, right? 12 over 20 down here. All right, so the change, right? The change is the sign. We're changing it from division into multiplication, right? We want to times, right? Because we know how to times fractions. And the flip is talking about the second fraction, which is 3 over 4. We flip it to 4 over 3, right? We just switch those numbers. And that has a real word. When we flip a fraction in math, it's called a reciprocal. It's called a reciprocal. So we are multiplying by this reciprocal. So we have two things we could do here, okay? The first thing we can do is we can times this fraction and then simplify it. Then we can reduce it at the end. Or we could reduce it right now and then times later. So I'm going to show both methods because some kids like to reduce first and some like to multiply first and then reduce later. So let's start by timesing first, right? So 12 times 4 is 48, right? And 20 times 3 is 60. So this fraction is correct. It's just not reduced. I need to figure out the greatest common factor, the greatest number, the biggest number that goes into both 48 and 60. And I think it's 12. I think it's 12. Yeah. So if we divide by the greatest common factor, and if we divide, it'll tell us what this fraction reduces to. So 48 divided by 12 should be 4. And 60 divided by 12 is 5. So it looks like this fraction, it looks like 12 20ths divided by 3/4 is 4/5. Okay, so if you like to do it that way, do it that way, right? Times first, then reduce. Some of you like to cross cancel, right? And cross canceling, we're looking for the greatest common factor between these two things. So
all student council members, please report back to Ms. Epperson's room. All student council members, please report back to Ms. Epperson's room.
Whew, okay, so 12 and 3, right? 12 and 3, the greatest common factor between those two is 3. So if we divide by 3, this is 1. 12 divided by 3 is a 4. Okay. Reminder, if you don't like the cross cancel or this is new to you, just do this one, right? You can skip this part of the video. Just do it this way, right? So the greatest common factor between 4 and 20 is 4. So 4 divided by 4 is 1, and 20 divided by 4 is 5. And now we can times 4 times 1 is 4, and 5 times 1 is 5, which is exactly what we thought it should be, right? We thought it should be 4 over 5. All right, so we're going to try one more, right, with this fraction, right? So I ask you to start what is happening between the fraction and the variable. What's going on when we have a number like that, -7/9, a number and a variable that's like right next to it, multiplying. I just gave it away, right? They're multiplying. I couldn't resist, okay? They're multiplying, right? They're timesing each other. So what is the opposite, right? Our instructions are to solve. And to solve, we need to do the opposite first. So what's the opposite of timesing? Well, it's dividing, right? And this is why this problem is like this one. We are going to divide by this fraction, right? And I will do that over here as well, right? So remember, we do the opposite because we want them to cancel, right? So everything's canceled. We're left with D, okay? We're left with D. And now we are dividing, right? And we have a whole number that's dividing this fraction. So I'm just going to make this 5 as a 5/1. And hopefully we didn't forget in the last, 2 minutes how do we divide fractions? We use that mnemonic, which is keep, change, flip, right? Keep, change, flip. We are doing the KCF here. So just a reminder that the keep is talking about the first fraction, right? We will keep 5 over 1 as 5 over 1, right? I don't know if we can see that green sheet. Does that look a little shady there? I might try the purple here. Let's try a purple one here. So I've got 5 over 1, which is 5 over 1. Change, right? Change is talking about division, right? So if I divide, now it changes to multiply, right? We are changing that. And the flip is talking about the last fraction, right? This negative 7 over 9, okay, is going to be flipped into 9 over negative 7. Okay, 9 over, we flipped it. That is the reciprocal, right? It's the reciprocal. Now, just as a reminder, okay, this problem can only be done one way. We can't cross cancel right now. There's nothing to cancel. So we are going to time straight across, and then that will be our answer. 5 times 9 is 45, and I have a 1 times a negative 7 is negative 7. And this is something that some of us might know, some of us not. It doesn't matter if the negative is on the bottom or on the top, or if we just put it in front of the fraction, right? We can write all of our answers. This is okay. This is okay. And this is okay. All 3 of those answers are okay. And you know me, we can also write this as a mixed number if you want, right? 7 goes into 45, I think 6 times. So I'm going to say, and it's negative. So negative 6, right? And so 7 times 6 is 42. The remainder between 42 and 45 is 3. Right? So it looks like we could also write it this way. Right? It looks like we could also write it that way. Okay, so I want you to try 3 problems, right? And these ones, right, as you're working, right, I want you to take a quick pause. I'm actually going to put them on the board. I will solve them like with us so you can see how they're working, okay? But I want you to go to page 461, please, 461, okay? And on page 461, you're going to do 3 problems for me right now. 3 problems. Those problems are 1, 4, and 5. So go ahead and pause your video, and then when you're done, check it out on my board up here, okay? Okay, let's take a look. All right, first off, the first one's easy, right? The 1.2 is multiplying this 6. Okay, so the opposite of multiplication is division. I will divide by 1.2. And remember, we do the opposite so these cancel, right? So we can get rid of those. That's the whole point, doing the opposite. If you use your calculator, 6 divided by 1.2, I believe is 5. Looks like X was 5 in that first problem. Right, so 4, right? 4 we are also timesing, right? This fraction is timesing the t. The opposite of timesing is dividing, right? We're going to divide by 2/5, okay? And this is a fraction problem, right? The opposites cancel, so we're left with t equals. We're going to use keep, change, flip, right? Keep, change, flip. So the 12 over 25 will keep. The change is the division sign into multiplication, and the flip is the 2 over 5 becomes 5 over 2. Okay, you can cross cancel this if you want. I'm going to times it first, and then I will reduce. 12 times 5 is 60, and 25 times 2 is 50. And we can obviously divide both these numbers by 10. You could get 6 over 5, or you could write it as 1 and 1/5. Either answer is fine by me. Right, so 5 has a little bit of a curveball here. It's got this mixed number, which I am going to start by turning into an improper fraction. Hopefully we all tried that. Okay, I've got 3 times a negative 3, right? So this should be a negative 9. It's a negative 10 over 3. It looks like, right? So we add down negative 10 over 3, and it's equal to this negative 1/2 g. So let's look at this fraction and the g over here, right? They are timesing, right? There's nothing in the middle there. They're not subtracting. They're just a negative sign. So let's do division. Let's divide, okay? Let's divide by negative 1/2. So I have this negative 10 over 3 divided by negative 1 over 2, okay? Negative 1 over 2. And these cancel, right? So we divide fractions, keep change, flip. The negative 10 over 3 is what keeps. The division becomes multiplication. We flip the negative 2, the negative 1/2 into 2 over negative 1. Once again, you can you can't cross cancel here, so we will just times them. Negative times a positive is a negative 20, and a negative 1 times a 3 is a negative 3. And if we have two negatives, right? If we're dividing, negative divided by negative, they make a positive. You can leave your answer as 20 over 3. You can also turn it into a mixed number, which I think is 6 2/3. That sounds right. Okay. All right. Thank you for watching. Your instructor is going to have the next part of the lesson for you. Good luck.